Well, hello everyone. Today we're going to work on section 10-3 double angle and half angle formulas. So these now, since this is the third section of the chapter, we've gotten into these. I'm not going to derive this part because the derivation is fairly simple and it's in your book, so I don't need to go over that again unless you have questions. If you have questions, please do ask. I'd like to start out with a couple of little warm-up problems for you, and you may want to read these and then stop the video for just a moment while you work them. So let's try one. What if you add 1 minus 2 sine squared 25 degrees? You could check that one out and think about it. You may want to stop the video at this time and work it because I am going to reveal the answer. And using your table on page 383, you can see there's one that says cosine 2 alpha equals 1 minus 2 sine squared alpha. It's written in this order, and that's why I did it. So they gave you one that looks just like this. Pretty straightforward. If your alpha then is 25, 2 alpha is 50. So this one is simply cosine of 50 degrees. Pretty cool. I like it. Okay, let's try another one. Have one here. Not too bad. Cosine squared 25 degrees minus sine squared 25 degrees. And I know you're thinking, oh, sine squared minus cosine squared equals 1, but that's not true. It's sine squared plus cosine squared equals 1. In this case, it's minus, so don't get misled that way. So again, use your double angle and half angle formulas to find something that looks like that. And indeed, there is one. And again, you may want to take a moment, stop the video right now and try to figure that out. But when you do, you'll find that that equals the sine of 50 degrees. Very handy. Let's do one more before we move on. Just a little warm up. 4. Got 4 in the brain. Well, I'm here. I want to shout out to Raven for his wonderful performance in the Mr. and Miss Central pageant Saturday night. That was cool. Nicely done, Raven. So, what about this one? Kind of our continuing theme here. Square root of 1 minus cosine of 100. Ooh, this one's looking scary. Divided by 2. Using your double angle and half angle formulas, there is one exactly like that. So check it out. And again, you may want to stop. And you will wind up with, I'm hesitating in case you didn't stop, equals the sine of 50 degrees. Pretty cool. Very useful. All right, now I'm going to start a new page and work a few example problems. Oftentimes you'll start off with something like simplify sine squared alpha over 2, it's like a half angle to me, minus cosine squared alpha over 2. And again, that's very similar to the one we just saw in the warm-up. One technique I want to talk about is using little substitutions to make your life easier. And that's fine. You can say let alpha over 2 equal theta. That's cool. Makes it simple. And then you can say sine squared minus cosine squared. Instead of alpha over 2, you can just write theta. And then it looks a lot like the one we just did in the warm-up. Pretty straightforward. And we can say that this is the opposite of cosine squared alpha minus sine squared, I said alpha, theta, my bad, right here, my bad, cosine squared theta minus sine squared theta, and that equals, from your table, the opposite of cosine 2 theta. Notice, and I could put these in parentheses maybe to help this look a little better. Don't forget it's the opposite of that. But just like we did up here, well, maybe I'll leave it. We did on the previous page in the warm-up, this whole part right here simply becomes cosine 2 theta, which is nice. And then take the opposite sign, and then before you're done, substitute back in what you started with here. So we get equals the opposite of cosine of 2 times alpha over 2. And that equals the opposite of cosine of alpha. And then you're done. Pretty cool. I like that a lot. Talk about that with your classmates, math cousins, if you need to. But it's not horrible. Pause, rerun this again if you need to. But yeah, once you start getting used to these, you definitely see that they're not bad, and they allow you to do a lot of tricks. I need a mouse. There it is. Okay, let's do another one. I went too far. Okay. So far, we've just done a lot of alphas and thetas and non-specific angles. Well, I guess we did some in the warm-up, so that's not true. We can say find the sine of negative 67.5 degrees. And I know what you're thinking when you first see that. You're going to run for your calculator. But you can do it without a calculator using the double angle and half angle formulas. So let's check it out. So to begin with, 67.5 degrees, you look at that and it looks ugly. But if you think about it in terms of, well, is it related to any angle that's a little bit nicer? The answer to that is yes, because you can take 67.5 degrees times 2, and you get 135 degrees. And that's a much, much easier angle to deal with. 135 degrees. Remember, on your unit circle is in quadrant 2, and it's right up there in quadrant 2, where these two are congruent, and using your unit circle, it looks a whole lot like its reference angle, 45 over here. So the coordinates for this are going to be the opposite, square root of 2 over 2, and square root of 2 over 2. So we've seen this one before. So instead of this kind of ugly negative 67.5, oh, and I should say a negative will be down here. Maybe I should have drawn it down there. I just drew it over here because I was thinking 135, but it'll actually be a negative. But same. In this case, it would be, let's change these coordinates around just a little bit. No crisis. They're going to wind up being down here. You know, I love parentheses. Here we go. And this one is going to be positive. This one is going to be negative. Again, that'll be down quadrant 4. So I made a little mistake, but not a critical one. We can move this angle down here if you want to. You get it. You can even move that point. Not a big deal. Okay. Square root of 2 over 2. So let's check this out. Now, find the sine of the opposite of 67.5 degrees. So we have the sine of opposite, in this case of 135 degrees over 2. And that then is going to equal, let's look in our double angle, half angle formulas at this time. You may want to pause, look around, try to find something that is usable. And sure enough, you find the opposite of square root of 1 minus cosine of negative 135. Notice it's just negative 135, not divided by 2, which makes life easier. And then the whole thing under the radical divided by 2. And then we can say that equals the opposite of the square root of 1 minus, and we can check out over here. There it is. There it is. 135 negative square root of 2 over 2. And I should say negative 135 is going to wind up being over here. So again, got to kind of, in your mind, think about your quadrants. Negative 135 is going to wind up over here, looking like that. And then that angle is right there. So again, in this case, the coordinates are down here in quadrant 3. But we don't need to freak out about that. It's okay. So that's why this one is a negative square root of 2 over 2. Oh, and don't forget, divided by 2. Okay? Equals opposite of the square root of 2 plus square root of 2 over 4. You may want to add one more step in there, but you can see where this came from. If not, talk amongst yourselves. Equals negative. You can pull out a 1/2 times the square root of 2 plus square root of 2. And I know what you're thinking. You're going, wait a minute, you've got a radical under a radical. Yeah, man, that's radical. And it's okay. And at this point, a lot of you are saying, well, that's ugly. That can't possibly be the answer. But yes, it can. And you decimal advocates, notice I didn't say decimal freaks. You decimal advocates are saying, well, it's a lot easier just to do that as a decimal. But we just did this whole thing without a calculator, which makes us powerful. Okay, I'm going to call this a good one. We have two examples here. You may need to watch them, especially this part here. I went kind of fast, but I was looking at my timer. I think it's time to wrap it up. You're probably tired of my voice. So spend some time on these. Keep busy. Keep working together. In my absence, I know that you'll make some good progress. All right. Thank you all. Gonna wrap that back up to the top and have a great day. Bye now.